TA. Today we have a contestant, Danny Lee from LA. How are you today, Danny?
Great.
You ready for this?
Hell yeah.
Okay, that's good. Good spirit. Well, just so you know, if you're in trouble, you have two cards to use. The first card is called elimination. You can use it to eliminate 2 choices out of 4. Second card is called call out. You can use that card to call to anybody, your friends, family members, anybody you know, to ask for possible answers to the questions.
Okay.
So no worries about it. Alright, so we'll start. So, question 1. What factors does a phosphorylated CTD bind? A. Splicing factors. B. Poly-A factors. C. All the above. And D. None of the above.
I would go with C.
C. Is that a final answer?
Yes.
And you got it right! Okay, but we'll still look at the clip though. And here it is. The transcription factor TF2H comes in and phosphorylates CTD, which is also the C-terminal domain of RNA polymerase II. So when it's phosphorylated, it signals the transition from initiation to elongation. Also when phosphorylated, it has the ability to recruit the splicing factors and the poly-A factors, and then they capped it to the pre-mRNA. Alright, good job!
Thank you.
Alright, here's question 2. So what pulses RNA? A. Nucleotide. B. Nucleosome. C. Nucleus. And D. Nucleolus.
C. Wait. Nucleosome. B.
Is that a final answer?
Yes.
You sure about this?
Yes.
Okay, and you got it right again! Okay, let's look at the explanation.
This is the DNA here, and this is little ping pong ball here is the RNA polymerase. And this blue thing here is the mRNA being synthesized. As RNA polymerase moves on the single-strand DNA, a nucleosome may come and bind to the GC-rich sequence on the single-strand DNA. And this binding will slow down the RNA polymerase and cause RNA polymerase to pause. And this is the RNA polymerase pausing.
Okay, great job, Danny. Here's question 3. Which splicing factor binds the branch point site, or BPS? A. U1. B. U2. C. U4. And D. U6.
I choose call.
You want to call?
Yes.
Who do you want to call?
Biochem professor.
Okay, go ahead.
Hello? Yes. Who is this? Danny? Yes. Oh, you're in the show. The splicing factor. Well, it's 2. Yeah, it's 2 for sure. It's U2. U2. Trust me. Trust me. I'm holding it in my hand right now. It's U2.
Okay, I got it. Thank you, professor. The answer is U2.
U2. B. U2. Are you sure about this?
Yes.
Okay, and the answer is correct. Woo! Here is the explanation.
This is the formation of spliceosome. This one here is the double-stranded helix DNA, and this is the transcription bubble. The blue tape here are the introns in the mRNA, and the white tapes here are the exons. And all these are the transcription factors. Transcription factor U1 binds the 5' splice site first, and then U2 binds the branch point site. And then U4, U6, and U5 comes and joins U1 and U2, which forms the spliceosome. And then U4 leaves U6, which activates U6, and U6 displaces U1 and binds to the 5' splice site. Within U2 and U6, the lariat structure gets formed. And now notice that we have a free 3' OH group in the exon. And this exon attacks the 5' phosphate group of the another exon. And this attack happens within U5. And then the intron gets spliced out and the spliceosome can leave. And now we have an exon connects to another exon, and the splicing is complete.
Alright, Danny. This is your final question. You get this right, you become a biochem TA. Are you ready?
Yes.
Here it is. Final question. What determines the skipping of an exon? A. GC rich sequencing exon. B. Length of exon. C. Exon-exon interaction. And D. Binding affinity.
I'll go with elimination since this is my last question.
Okay, sure.
Yes.
Go ahead, use the card.
Okay.
Okay, so B and C are gone. You're left with A, GC rich sequencing exon, or D, the binding affinity.
I'll go with D.
You go with D, binding
Yes.
affinity. Are you sure about this?
Yes.
Okay. And that's correct. Congrats! You're now biochem TA. Explanation of the question.
When mRNA is transcribed at a slower rate, the splicing factors have sufficient time to bind to the immediate exons before the newer exon is transcribed, leading to splicing without skipping. When mRNA transcribed at a faster rate, multiple exons become available for the splicing factor to bind to. In this case, the splicing factor will bind to the exons with the stronger affinity, causing a splicing. The one with the exon with the weaker affinity, in this case this one, will be spliced out with the intron, causing exon skipping.
Thank you for watching. Tune in next time again for Who Wants to Be a Biochem TA? Good night.